Hello. Welcome to this next installment of the Honors Pre-Calculus video tutorial series. We're working on Chapter 10, Section 3 in Statistics, and this is Part B of the lecture. And let's take a look at an example so we can learn how to identify an outlier. First, remember that an outlier is a number in a data set is an outlier if it is more than 1.5 times the interquartile range. That's the difference between the first quartile and the third quartile. So we'll take a look at Roger Maris's annual home run totals, and we'll go ahead and figure out the 5 basic numbers: the minimum, maximum, the median, the first quartile, the second quartile. We'll calculate the interquartile range, and we'll decide whether 61 is an outlier. So first we need to write the numbers in order. When we put the numbers in order like this, the 61 certainly does look like it's a bit of an outlier. So let's go ahead and calculate the various things that we need to calculate. The min and the max, of course, are 5 and 61. There are 12 data points, so the median is going to be the value in between the 6th and 7th. That's between 16 and 7 and 23. They add to 39, so the median is half of 39, or 19.5. To calculate the first quartile, we throw away the median, and since it isn't a point, that's not hard to do. Just take the bottom 6 elements, so we're looking for the value right between 9 and 13, which is 11. And the third quartile is the number right between 28 and 33. If you add those, they add to 61, so 30.5. So the 5-number summary is 5, 11, 19.5, 30.5, and 61. So, what's the interquartile range? Apparently it's 19.5, which by a total coincidence is also the median. That is just pure coincidence, though. Don't notice anything of that. So let's multiply the interquartile range times 1.5. That's 19.5 times 1.5. And that is 29.25. So in order for a number not to be an outlier, it would have to be within 29.25 points above the third quartile or below the first quartile. And that means that the maximum number that he had for annual home runs of 61 is a little bit larger than the 1.5 times the interquartile range added to the third quartile. So that makes 61 an outlier. In the next figure, we'll see a box and whisker plot, or a box plot, of Roger Maris's annual home run totals if we leave the outlier out and stop at the other maximum of 39, and then sort of recalculate everything, and we get the following. Notice the right whisker from the third quartile to the max no longer goes to the 61 score because it's been judged an outlier, and everything has been recalculated without it. You can see that the whisker and the portion of the box to the right of the median are a bit longer than they are to the left, so one of the things we can tell from this box and whisker plot is that the distribution is slightly skewed to the right. For the next example, let's reconsider the table that we had of male and female life expectancy data from example 3. Here's that data again so you can review it. Now obviously what you would have to do here, and I'm not going to go through all the steps, but you'd have to rank in order the male and female life expectancies for the countries. You'd have to calculate the 5 numbers, and then you would have to decide if there are any outliers, and then finally graph it. And here's the result. I'm just going to go ahead and show it. This image provides a very good visual summary We've thrown out one male outlier and two female outliers, and you can see a couple of things. You can see that the distribution of the range of males and females. The females is a little bit tighter, more restricted range. Life expectancies don't vary quite as much as males. The male tends to be skewed left. The female tends to be, it's hard to say. Looks about even. But the key thing is that the median for the female life expectancy in these South American countries is significantly higher than the male. All right, so for our next question, we're going to look at a frequency table. So looking over example 6, we see that these are grades on a 10-point quiz for a class. We can see one student got a 0, one got a 1, one got a 2, two got 3s, 3 got 4s, and so on. To figure out how many quizzes there are, we just add up the frequencies. So 2 and 2 is 4, and 3 is 7, and 8 is 15, and 4, 19, 22, 25, 25, and 5, there are 30 students in the class. So the 5-number summary. Well, the min and max are pretty obviously 0 and 10. Since there are 30 scores, which is an even number, the median would be right in between the 15th and the 16th scores. Now, you could write out all of the scores starting with, for instance, 2 10s, 2 9s, etc., and count through them. We should be able to do this by thinking it through pretty easily. We want to find the 15th score. To do this, we'll just add up the frequencies from the right. So 1 and 1 and 1, that's 3, and 2 is 5, and 3 is 8, and 3 is 11, and 4 is 15. So the 15th score is a 6, and the 16th score would be a 7, so that means the median is a 6.5. Now I go ahead and I split the upper and lower half, and since there are a total of 30 scores we found, we throw out the median, which is 6.5, which doesn't really exist, so I've got 15 on either side. So splitting that right down in the middle, the 8th has 7 below it and 7 above it. So I want to find the 8th score. So 1 and 1 is 2, and 1 is 3, and 2 is 5, and 3 is 8. The 8th score is a 4. So that's the first quartile. And then we could either count up from the median or down from the top, but we want to go 8 scores down from the top. So counting down, 2 and 2 is 4, and 3 is 7, and 1 looks like a 7 would be the third quartile. Now we can calculate the interquartile range. And that's 7 minus 4, which is 3. And then I multiply that times 1.5, and I get 4.5. So a number will be an outlier if it's more than 4.5 above 7. That would be 11.5, and everything's inside that. Or if it's further than 4.5 away from the first quartile, which is 4, and that would be below negative 0.5. So we should be able to see pretty clearly that in this case there are no outliers. I hope this has been helpful. This is the second video tutorial, and it concludes the second video tutorial for 10.3 on numerical statistics. Should be able to finish up this section in the third video tutorial.